Hello everyone, welcome to Solid State Physics course. So in this course we discussed unit 1, now we entered into unit 2. So now today we are going to discuss about Miller indices. This is the second lecture in unit 2. Now let us discuss about Miller indices in this unit cell. Okay, let us see. This is the unit 2 of the crystal planes and X-ray diffraction. This is what syllabus of the unit 2. Hello everyone, welcome to Solid State Physics course. So in the previous lectures we discussed about unit 1 and next unit 2 X-ray diffraction crystal planes. So in the part of unit 2 today we are going to discuss about Miller indices. So now let us discuss about Miller indices. Hello everyone, welcome to engineering physics course. So previous lectures we discussed about unit 1 and we entered unit 2. In the part of unit 2, today we are going to discuss about Miller indices. So let us see what is the Miller indices. So this is the syllabus of unit 2, this already we know. So before discussing Miller indices, let us recall what we discussed in previous lecture. In previous lecture we discussed about crystal planes. Crystal planes are imaginary planes inside a crystal where the atomic density is large. That means if we imagine a two-dimensional planes in a crystal or having atoms on it, those are called atomic planes. So these atomic planes we have seen the different orientation of planes we have seen, and now those are also parallel planes, the same plane with the same orientation. We can observe a more number of parallel planes inside a crystal. That means such planes are having different orientations also we have seen in the previous lecture. Now today our point is that if the planes are in two-dimensional representation, if the planes are different orientation and parallel planes are there, then how can we identify what is this plane? Then how can we name it that plane? How can we say some plane is in this orientation, another plane is another orientation? How can we say this is this plane, this is this plane? So for that, Miller is a scientist. He was given some notation in order to identify the plane, especially the orientation of a plane. So he has given some notations. How to index those planes also we are going to discuss in today's lecture. So here this is a plane, one plane is like this, another plane is like this. Now if I say this plane is rectangular plane and this plane is a triangular plane. Now this is also triangular plane, but this is different from this one, if the different orientation. Now how can you distinguish this plane? So that's that thing we are going to discuss. But before that I just wanted to say that the axis you have to take in throughout this course, that is fixed. So always you take x-axis in the perpendicular to this one, normal direction, and y-axis in this direction and z-axis in this direction. See here, if you say body-centered cubic structure, always you take this direction is x and this direction is y and this direction is z direction. That you have to follow, and everyone should follow the same notation throughout this course. Now let us see, this is the unit cell. If you take on x direction, the length of the unit cell is, this is the lattice parameter where the unit cell length on x-axis is a, and along y-axis it is b, along z-axis it is c. That means this is a unit cell is having the lattice parameters A and B and C. Now let's see, if you have a plane is like this, then this plane is like this. Now the question is here, how to identify this plane? How to identify this plane? So that is our question. Okay, now the plane is like this. Okay, this is the plane which is touching at an x-axis, y-axis and z-axis. Now we have to have some name of this plane. How to give the name to this one? That means how to identify, how to call this plane. So that is what? How to represent this plane? That is our question. So we have to solve. For that, Miller has given some notation. What he said that what are the planes are in a crystal, if you take those planes, then take intercepts of those planes, the reciprocals of the intercepts of that plane with a crystallographic axis, that gives the Miller indices. That means Miller indices is only representation of the orientation of the plane. That means if you take a plane, the orientation of that plane, that gives the Miller indices. How to do this one, Miller indices? Before going to that he has given some notations. We can call the planes, okay, with some notation. Okay, what are the notations? Let us see. If you represent a plane, crystal plane, that always the plane is, we can say in brackets HKL. For example, 1 1 1 plane, 1 bar 1 plane. 1 bar means it is a -1. -1 we can represent with a 1 bar. According to Miller, that notation we have to follow. Family of crystal planes. Family of crystal plane means 1 1 1. What are the family of crystal planes? For example, if you take a plane of 1 1 1 and 1 bar 1 1, that means same planes which are having different notations, that are called family of planes. So those family of planes, if you try to represent more number of planes, then we have to put a square bracket. The curly bracket is like this, HKL. So for representing family of planes, you have to keep curly brackets HKL. Direction of plane. If you say this is the direction of the plane, for that your representation should be with a square bracket of HKL. Similarly, family of planes direction. Direction of the family of planes, you have to keep in less than greater than within the less than greater than HKL. HKL are Miller indices. So this is the notation of the plane. Whenever you write it, you write something like 1 1 1 within a one normal brackets, that is represent plane. If you write with a curly bracket, that is a family of planes. So you have to be careful. Now let us see how to find Miller indices. So first we go for stepwise. What is step 1? Identify the intercept of that plane with a axis, XYZ axis. First you have to identify. So if they identify that intercept, and what you have to do in step 2, you have to divide with the primitives, means with the lattice parameters, you have to divide with that. And third step, take reciprocals of that intercepts. You take reciprocals that intercept. Let's say here example is given. If you say intercept is PA, QB, RC. Now step 2, you have to divide with a PA by A, QB by B, RC. That PQR is coming. Now whatever that is coming, in third step you have to take reciprocals, 1 by P, 1 by Q and 1 by R. And now what you have to do, you take some LCM. If it is in fractions, it is in fractions. So take LCM and convert that fractions into the integer, smallest integer, by multiplying with a LCM. So then what are the final numbers, if you keep in a bracket, that is Miller indices of a given plane. So this is the procedure. So you have 6 steps to follow to convert a plane into the Miller indices. Okay. Now let us see, for example, if it is a crystallographic axis, x, y, z is there. Now unit cell is like this. For example, if you define unit cell is like this, along x direction, this unit cell is touching here. That means this length is, we can say it is p into a. A means it is a lattice parameter. So this is what the length of the lattice parameter. That means this is a, and a, 3a, something like fraction is coming. That's why I am keeping here p into a. Something here also on y-axis you always present with the intercept is qb. Along z-axis it is a rc. So that's why PA, x-intercept is PA, y-intercept is QB, z-intercept is R. P, Q, R are any number. Like it is a maybe 1.5, 1.5, 3.5 like that. So always it is multiple with a lattice parameter. Now let us find Miller indices of this plane. So for this, what is the step 1? Step 1, you have to identify intercepts, x-intercept, y-intercept and z-intercept. Here x-intercept means here it is touching here. That means what is this length? It is a. So you write x-intercept is a, y-intercept is b. What is z-intercept? Z-intercept is c. This is the step 1. Next step 2, what you have to do? You have to divide with the primitives. That means lattice parameters means a by a is equal to 1. B by b is equal to 1. C by c that is equal to 1. What it come? 1, 1, 1 has come. Now what is the step 3? You take reciprocals of whatever coming in a step 2. 1 by 1, 1 by 1. That means 1 by 1 means this is 1. 1 by 1 means 1. Here also 1 by 1, this is 1. So 1, 1, 1 is coming. Now what is step 4? You have to take LCM. When LCM you will take, if there is a fraction cell, there is no fractions. 1, 1, 1 is clear. So you need not go for LCM. So you keep that one, what are the left outs, 1, 1 in a bracket. So this is called Miller indices of this plane. So this is what? This is H, K, L. Here H is equal to 1, K is equal to 1, L is equal to 1. That means we can call this plane is 1, 1, 1 plane. Whenever the orientation of the plane is like this, we can say it is a 1, 1, 1 plane. Right? Now, let us see next example. In this example, the plane is different. Okay. We'll follow the steps. First step, you take intercepts. An x-intercept is, this is x-intercept. This is length is a. Y-intercept, it is touching here. The length is given, it is b by 2. So it is b by 2. And z-intercept, it is given c. That means it is touching here. The length is c. So intercept value is here c. Now step 2. What is step 2? You have to divisible with the primitives. That means lattice parameter. That means a by a. A by a means 1. Next, you have to divide with a b. That means b by 2 by b means it is 1 by 2. C by C, that is equal to 1. So what you get? 1, 1 by 2, 1 you got. What is step 3? You have to take reciprocals. Here it is 1, that means 1 by 1. That means it is 1. Here 1 by 2, that means 1 by 2. That means how much? It is 2. Here again 1 by 1, that is equal to 1. So what you got? 1, 2, 1 you are getting. So now there is no fractions are there. Directly you can take it as a Miller indices. That means 1, 2, 1. This is the Miller indices. That means HKL. 1 to 1. That means this plane we can call is 1 to 1 plane. 1 to 1 plane. Right? Now let us discuss next. Before that, I just wanted to give some important features of Miller indices. So something like encountered in while doing this Miller indices, conversion of the Miller indices, planes into Miller indices, we have to have some clarifications as given by the Miller indices. Those we can call it as important features. What are those? Whatever the Miller indices we are representing, that is the orientation of that plane. If there is a intercept is coming in a negative direction, or if there is no intercept is coming, that means the plane never touches the axis, either x or neither x nor y or not z. That means then you can take that intercept as infinity. You should not take it as a 0, that is infinity. And now if the intercept is negative, that means in negative x direction, if the plane is intercepting, then you can take it as a bar. That means 1 bar minus 1. And all parallel planes is having the same Miller indices. That means if you take one orientation of the plane, if you take the successive, the same parallel planes, all are having the same Miller indices. Okay, so that we represent with a HKL. So the intercepts made by the axis, that is the, and the last one is, if you know the HKL values, if you want to find the what is the intercept value, then that intercept is A by H, B by K and C by L. For example, if you know the intercepts A, B, C, then you are converting into the HKL. But in reverse way, if you have a HKL value, then you want to find intercept, then that intercept is A by H, B by K and C by L. So these are the important features of the Miller indices. Now let us do the same exercise for this plane, right? Okay, let us find Miller indices of this plane. The special of this plane is, let us see here, in first step we have to find intercept. See, it doesn't touch anywhere on x-axis. That means this plane is parallel to x-axis. This is same parallel to x-axis. When there is a parallel that is not touching and it is parallel, according to Miller important features, what is that? You have to take it as a infinity. Intercept is infinity. It is not 0, it is infinity. Similarly, on y-axis, what is the intercept? Yeah, it is touching here. That means the intercept is B. Y-axis, z-axis, if you take again, it is not touching the z-axis. So that means it is parallel to z-axis. So that we have to take intercept is infinity. Now in second step, you have to divide with a primitives. That means infinity by A. Infinity by A. So always it is infinity. B by B. B by B. That means it is 1. Again infinity by C. It is infinity. Now you got infinity, 1 and infinity. Third step, you have to take reciprocals, means 1 by infinity means that is what? 0. right? Again 1 by 1 means it is 1. Here 1 by infinity means it is 0. Then what you get? Directly you can write there is no fractions are there, so HKL is here 0, 1, 0. The plane of this type of orientation of this plane is, we can say it is a 0, 1, 0 plane. It is 0, 1, 0 plane. So by looking at here, 0, 0 is coming means x and z axis are parallel to this plane. By looking Miller indices also, we can say it is a parallel to x and z axis. That means it is on y axis, perpendicular to the y axis. That also we can write. We can say. Okay, next example. Let us see this one. Step 1. Yeah, tell me, x-axis, is there any touching on x-axis? No. Intercept is no. That means it is parallel to x-axis. Means here it is parallel to x-axis. Similarly on y-axis, it is nowhere it is touching. That means it is parallel to y-axis. So it is also y-intercept also infinity. And again z-intercept here it is touching here, that means the length is c here. Then step 2 is what? You have to divide with the primitives. That means infinity by a means it is directly infinity. Infinity by b means it is infinity. C by c means it is 1. Now third step, you take reciprocals, means 1 by infinity. 1 by infinity means 0. 1 by infinity means 0. 1 by 1 means 1. So this plane HKL is equal to 0, 0, 1. This plane we represent with a 0, 0, 1. This plane we can say it is a parallel to x and y axis and perpendicular to the z axis. Right. Okay, let's see next one. Here in this case, let's see an x-axis. X-intercept is what? Here it is touching. The length is a. That means step 1, the lattice and x-intercept is a. Again y-intercept, it is touching on y-axis. The y-intercept is b. Z-intercept, if we take it, nowhere it is touching. This is z-axis, it is like this. That means this plane is like this. Like this. Okay. So this type of plane. So it nowhere it touches the plane. So if you carefully if you see, then this is this plane. This plane. Okay. It nowhere it touches the z axis. So it doesn't touch the z axis. That means the z intercept is infinity. Now step 2 is what? We have to divide with the lattice parameter. A by a means 1, b by b means 1, and it is infinity by c means it is infinity. Step 3 is we have to reciprocals you have to take. That means 1 by 1 is 1, 1 by 1 is 1, 1 by infinity is 0. So therefore HKL of this plane, the Miller indices are 1, 1, 0. We can call this is 1, 1, 0 plane. 1, 1, 0 plane. So this is the Miller indices of this plane. That means this plane is only parallel to the z axis. Only parallel to the z axis. Let us go for next example. This is slightly oriented. The orientation is different from previous one. Here again on x-axis, what is the intercept value? So let us see this one. Here this plane is slightly different from previous one. Here on x-axis, x-intercept is a. So x-intercept is a. Again y-intercept, that means it is not touching on y-axis, that means intercept is infinity because it is parallel to y-axis. And z-axis, you take z-axis, the intercept here, it is touching here. It is touching here means the intercept is c. Now in step 2, you have to divide with a lattice parameter. That means a by a is 1, infinity by b means infinity, c by c means 1. Step 3, you take reciprocals. 1 by 1 means 1, 1 by infinity means 0, 1 by 1 is 1. So therefore HKL, Miller indices of this plane, is equal to 1, 0, 1. Now we can call it, this plane is 1, 0, 1 plane. Right. Okay, next example. This also we can write directly. It is touching on y-axis. Now in this, you can see directly you can write it is parallel to x-axis. It is parallel to x-axis means the intercept is infinity. Again it is touching on y-axis, that means intercept is b. Again it is touching on z-axis, intercept is c. So step 2 means this is infinity, 1, 1. Step 3 means it is 0, 1, 1. So the HKL of Miller indices of this plane is 0, 1, 1. So this plane we can call it as 0, 1, 1 plane. Right. Okay, next example. Okay, next example. In this example, let us see here. It is something like tricky that we have to be careful while doing this exercise. This plane for finding Miller indices is somewhat difficult. Why it is difficult? If you take step 1, if you see x-intercept, it is not touching on anywhere on x-axis, but at the same time it is not parallel to x-axis. It is not parallel to x-axis. So how to find x-intercept for this case? So for this case, whenever in a crystal, the lattice, if you take a lattice, the lattice by definition it is anywhere you go, you cannot distinguish wherever you are. That means neighborhood is same. That means you can keep anything, origin is anywhere. The answer is always is same. That means if you take this plane, if you keep on crystal in anywhere, the Miller indices always should be same, because it is everywhere it is identical. That's why there is a flexibility that you can shift origin in order to give Miller indices of such problems, such planes. You can shift the origin from this point to anywhere because it is identical. That means if I shift this origin from here to here, that means here this is my z-axis and this is my x-axis. That means I am shifting this origin from here to here, x, y and z. Now if you do it like this, let us see now x-intercept means this is my x-axis, means it is touching here. That means what is this length? This length is a, so this length is also a. So that the x-intercept is coming a. Again y-axis, if you see y-axis, it is not touching on y-axis but it is touching in back side. That means in negative y direction it is touching. The length is what? In negative direction means it is, the length is minus b. Similarly in z-axis it is touching on z-axis. This is z-axis. If I take, the length is c, that means the intercept is c. You understand? Just we are shifting our origin to from here to here because it is everywhere it is symmetric. Now step 2 is you have to divide with this one, lattice parameter 1, minus 1, 1. And third one, you take reciprocals means 1 by 1 means 1, minus 1 by 1 means minus 1, 1 by 1 is c. Now this is the There is no fractions are there. Directly you can write Miller indices of HKL is equal to 1 and minus 1 as per notation we have to write is 1 bar. This is 1.